When I first entered college as a student in mechanical engineering, I envisioned a job where I would primarily spend my days designing cutting edge aircraft using complex modeling applications combined with elaborate simulation software. The only logical next step was to get an internship at one of the big aerospace companies. At first, I completely ignored smaller manufacturing companies. If I hadn't heard of them before, then I didn't give them the time of day. I saw manufacturing engineering as lesser than the design and simulation work I saw myself doing. Manufacturing conjured up images of dark-lit factories with poor ventilation, and more importantly, a lack of CAD and FEA that I thought I wanted to do. Fast forward 5 more years, and I have been with the same aerospace manufacturing company since freshman year summer. Since then, I have learned that my preconceived notions were far from accurate. Today's video is meant to shed light on what a manufacturing engineer really does day to day. This is the day in a life as a manufacturing engineer in the aerospace industry. The aerospace industry is very large and widespread. At its core, the aerospace industry includes several different engineering disciplines, including mechanical engineering, manufacturing engineering, and quality engineering. Mechanical engineering primarily deals with design. They typically own the overall form, fit, and function of a very specific part within a system. They work in teams whose responsibilities encapsulate specific characteristics like aerodynamics, structures, or propulsion. Manufacturing engineers primarily deal with the construction and fabrication of those parts. They are responsible for the process used to produce the parts in accordance with specifications outlined in customer or end use blueprints. And finally, there are quality engineers that ensure manufacturing processes maintain proper adherence to customer specifications, blueprints, and procedures. These are primarily the ones that affect my line of work, but there are several other disciplines that also are relevant to manufacturing for aerospace, such as avionics and flight control engineers, which would affect more of the computer related hardware of an aerospace vehicle. In summary, mechanical engineers make the conceptual part and control requirements. Manufacturing engineers control the process and produce the physical part, and quality engineers make sure the physical part matches the conceptual one and that the process matches the requirements. At my company, we are a secondary supplier, so we produce parts that an original equipment manufacturer, or OEM, uses on their vehicles. This is very common, especially in the aerospace industry, and it is also typical for hundreds or even thousands of smaller suppliers to provide parts to the end use OEM. Similarly, we contract out certain processes that we cannot do in house, whether that be due to capacity reasons where we have the machine to perform the process but it is busy doing something else, or we simply don't have the machine or capability. As a manufacturing engineer, it is my core responsibility to design the overall process to make the part, coordinating everything from sourcing raw material to defining each operation leading up to the final product. As one can imagine, the process of creating a new process is complex and often requires lots of trials and testing and is referred to as New Product Introduction, or NPI. The process involves a series of design and implementation of fixtures, tool and die, and gauges. Fixtures secure parts in relation to a tool or die. They often constrain the part so that it moves or behaves in a controlled and expected way. Tool and die are the equipment that modify the form and fit of your part. They either add, subtract, or change the input part to match the expected output. They can be both manual or automated through machines, and are typically specific to the operation of a specific part. Gauges measure or assist in the measuring of a feature installed using the tool or die of the previous operation. They're designed to make inspection easier and quicker, or to act as a quick check for operators to know they are making good parts. Once all the equipment is designed, it must be proven through what's known as a first article inspection report, or a FAIR. FAIRs can either be internal or external. In the case of external, the customer's quality team would review your FAIR for specification compliance and part conformance. This allows them to know that the quality of the parts that you make meet their standards to purchase and are safe to use on their vehicles. FAIRs are also required when a significant process change has occurred, like changing from installing a feature using a CNC mill to using a laser cutter. Once a part has a proven process, it is almost certain that there will be abnormalities in that process. An abnormality is a deviation from the desired state of existence. In this case, it is something that can cause an interruption in the manufacturing process. Nonconformances such as a dimension being off, using the wrong equipment, processing a part out of sequence, or losing traceability on parts are all examples of things that may happen that would result in a part being brought to the Material Review Board, or MRB. This is a locked area of the factory that holds all the parts that are otherwise non-conforming, and it is the manufacturing and quality engineer's responsibility to review the non-conformance and assess how to fix it. If the non-conformance is fixable, they create a rework router, which provides a sequence in addition to the process the part normally goes through to ensure the nonconformance is fixed. If the nonconformance is unfixable, the part will be scrapped, which affects production by eliminating a part that could have otherwise been sold to the customer from inventory, and results in your company losing the money put into producing the part up into that point. When a nonconformance repeats, the quality and manufacturing team conduct a root cause corrective action, or RCCA. This is where the manufacturing engineer discovers the root cause of a nonconformance and makes a change in the process to stop it from happening again. Finding the root cause can be difficult and requires data collection or observation of any part of the process that would occur before the nonconformance was observed. For example, a part has a dimension that is shorter than normal. The sequence is as follows. The feature is installed on a CNC mill, then it is deburred, then the entire part is straightened. After that, the part enters a heat treat operation where the entire part is hardened. And finally, the part is brought to inspection where the nonconformance was found. In this case, any one of those operations could have caused the dimension to read shorter than normal. Perhaps the CNC program was wrong. Maybe the deburr was biased towards one end. Perhaps the straighten operation moves the feature inward, and the heat treat, which causes a known shrinkage in the material, may have not been properly accounted for. These are all things you need to consider when determining the root cause, and all of these operations would need to be observed to gain the clearest picture of where the nonconformance is actually occurring. Determining the root cause is only half the problem, though. As an engineer, you are paid to solve problems, hence the corrective action. In one of my previous videos, I briefly talked about Kaizen and its approach to solving abnormalities. These approaches include poke-yoke, otherwise known as idiot-proofing, which prevents the operator from loading a part the wrong way or using the wrong settings. The purpose of poke-yoke is to limit the inputs to only the absolute necessary ones, so there's no way for human error. Another technique is one touch. One touch is the art of reducing the physical steps required to achieve the outcome to the least amount possible. One button press activates the whole process. One lever presses a part to the perfect angle. Placing a part on a pressure pad activates an automated washing process. While it is extremely challenging, it offers the absolute minimum requirement for you to achieve your desired result and serves as the gold standard for creating solutions. One of my recent projects was modifying a fixture to use magnets on the top and bottom to hold parts rather than a series of manual lever clamps. Before, the operator would push down several manual lever clamps to sandwich a part between a top and bottom fixture. At different points in the program, the machine would stop, and the operator would undo certain clamps and push down others to allow the machine to cut different areas of the part while still holding down tight and thus not losing the positioning of the part. The abnormality is that the program has to stop halfway through, and the operator has to remember which clamps to do and which not to do. By replacing all the lever clamps with magnet inserts on the top and bottom of the fixture, the operator only needs to place the part on the fixture and then place the top fixture piece on, and it will automatically clamp itself together. Since there are no clamps, the machine is free to run on a single continuous sequence without any stops, thus removing a large degree of human error and minimizing the amount of touches required to begin the process. A manufacturing engineer is a person that makes the process that makes the parts. They design the sequence, tools, die, gauging, and fixturing that allows parts to follow from start to finish using specifications and blueprints outlined by the OEM. They coordinate quality compliance and conformance with the internal and customer quality teams for fairs. After the new product introduction stage, the engineer is responsible for the overall quality of their process, determining rework procedures for parts as necessary, and investigating root causes. Once a root cause is determined, their job is to fix it through creative die design and fixturing. I know this is all a lot to take in, but it pretty much covers everything a manufacturing engineer is responsible for day to day. When I started out 8 months ago, I had no idea what any of this was. I thought that all of engineering was working on the computer in CAD or running FEA simulations. If you are fresh from college, you may assume that all engineers perform multivariable calculus on the daily and even apply thermo regularly, but in many cases, that is not reality. Manufacturing is a very unique ecosystem with which the engineer acts as a liaison between every facet of the business. They coordinate processes to make the parts, they regularly interface with the quality team to ensure conformance and compliance, they make clarifications to operators and inspectors, and they design the processes to make parts on time to meet demand, ultimately affecting revenue and profit. As a whole, I would say that none of my classes directly prepared me for work as a manufacturing engineer. However, it is far more interesting than I would have ever imagined. My whole college existence, I was convinced that manufacturing wasn't cool enough to work in, and continuously tried and failed to get into the big OEM internship programs. What I didn't understand was that these OEM internship programs are often gated behind personal connections. And if you don't have those, you're likely waiting behind a line of thousands of other candidates with the same or better grades and experience. If I could go back in time, the one piece of advice that I would give myself is to try a manufacturing company that isn't one of these big OEMs. Do a quick Google search, or maybe even use ChatGPT to generate a list of suppliers for these OEMs, and then reach out to them. Not only will you be more likely to receive an opportunity from them, but you will also learn much more faster. Not only will you be more likely to receive an opportunity from them, but you will also learn far more faster than those bigger companies because they move at a glacial pace. Plus, as with all of manufacturing, you will have an opportunity to gain real hands on experience, touching physical parts daily and perhaps even learning how to make a precision part with your own hands and machining knowledge. The beauty of manufacturing is that it is far more complex than design. It may take a team of hundreds of engineers to create a conceptual idea for the next plane or jet, but it will take thousands of people to build the processes and coordinate the materials to bring that concept to life. Dare to become a manufacturing engineer, and you open yourself up to a world of knowledge you never knew existed. Thank you so much for watching, and have a great day.